Okay, so this is Mechanics, Year 2, Exercise 6C, and I'm going to do questions 12 and 14. So let's have a look at the first question. It's a stone is thrown from point A with speed 30 at an angle of 15 degrees below the horizontal, all labelled on this diagram. We start at 14 metres above the ground, and the stone strikes the ground at point B. We want to find the time it takes to go from A to B. Okay, that doesn't seem too bad. We probably need to set up 2 suvats and then go from there. So, first of all, I'm going to set up, well, actually, first of all, I'll resolve my forces to get the downwards force and the force to the right. So this is 30 sine 15, 30 cos 15. So I'm going to resolve downwards because the majority of the forces in terms of vertical are going downwards, so I'll get the least negative values this way. Plus it's my initial movement going downwards, so it makes sense to resolve downwards. Well, for it to travel A to B, I'm going to be going down that 14 metres to the ground, so a displacement of 14. My initial speed is going to be 30 sine 15. My final velocity, we don't know, we don't care. The acceleration is going to be gravity, positive this time because I'm taking downwards as positive. And the time is something I am concerned about. So let's go S equals ut plus half at squared. It's our favourite one with these types of questions. So 14 equals 2t 30 sine 15 plus 4.9 t squared. Let's make this equal to 0 so we can solve it. So take the 14 to the other side, and I'm going to do the quadratic formula. And I'm going to do that with A equals to 4.9, B equals to 30 sine 15, and C equals to 14. When I do that, I am going to get 1.0744. I'm also going to get minus 2.659. The minus 2.6 clearly doesn't make sense. That's kind of like if we completed the quadratic like that, and it's kind of taken that time back there. So this is my clear answer here. How that was worth 6 marks, I really don't know. But it was, so nice 6 marks. B, the distance. The distance A to B. Well, we know the time is this. Sorry, I should be rounding this, shouldn't I? Rounding this to 2 significant figures due to our accuracy of gravity. So 1.1. But in my next calculation, I will use that unrounded version, just to be extra precise. Well, in this one, to find the distance A to B, I want to resolve horizontally. S, well, that's actually what I'm trying to find. I'll call that X. The speed is 30 cos 15. We don't care about the final velocity. We have no acceleration because gravity is the only thing that affects this, and it doesn't affect horizontal forces. And then time, well, it's the same value of time from that previous question, so 1.0744. S equals to ut plus half at squared. Well, if A is 0, that all turns to 0. So it's just S equals to 30 cos 15 times by 1.0744. And that equals to 31.0 something. So 2 significant figures. 31 meters. So that's that question done. Just a little 2-mark question there. Okay, on to question 14. this one's got a little bit more to it. And it's another one of them was that I hate, where we have to use gravity as 10. It's annoying that they make us do that. I don't really see the point. But we'll go with it. They've labelled the diagram out pretty nicely for us, so we don't really need to add too much on. Maybe we just want to resolve these forces. So my force going horizontally will be u cos theta, and my force going vertically will be u sine theta. The next thing I pull from this question is that tan alpha equals to 5 over 12. So that means I've got a right-angled triangle where the opposite is 5 and the adjacent is 12, because opposite over adjacent for tan. This will be 13 via Pythagoras. So sine alpha is going to be opposite over hypotenuse, and cos alpha is going to be adjacent over hypotenuse. I therefore know, actually, that I can call this 12 over 13u, and I can call this 5 over 13u. So I don't have to mess with sines and coses anymore at any stage. So that is everything from the question. So let's just crack on with it. So we want to find the value of u, so the value of the speed, or the initial velocity, the initial speed. So how we're going to go about that, there's no real obvious first thing to do, I don't think. So I am going to set up some equations in terms of vertical and horizontal, and I'll see where that leads me. It's always a good starting point. If you're unsure what to do, just start doing suvats for vertical and horizontal, and then it will give the picture a little bit clear about what you might do. So I'm going to do this for it hitting the ground. So this is for A to B, so that will be kind of my values for displacement, etc. So when it goes A and then when it hits the ground. So for this, my displacement is 25 down, so that's going to be minus 25. And then for the one across, my displacement is going to be 42 meters across, so positive 42. My speed in terms of horizontal is 5 over 13u, and then horizontal, that was vertical. Horizontal is 12 over 13u. Final velocities, we don't know anything about either of them. The gravity affects this, so that the acceleration of this will be minus 10, and the acceleration of this will be 0. And then time, well, we don't know. So we've got two unknowns. We've got an unknown of u in both, and we've got an unknown of t. So let's set up two equations, and then sub t in one place to eliminate it. So that's going to be our little method. If that doesn't quite make sense, you'll see what I'm doing when I get into this. So s equals to ut plus half at squared. So minus 25 equals to 5 over 13 ut plus half minus 10, so minus 5 t squared. I'll do this one, but I don't know if I need to simplify that yet. I'll do this one first. So s equals to ut plus half at squared, or 42 equals to 12 over 13 ut, and because a is 0, all of this is 0. So why don't we rearrange this to get t equals, and then substitute it into my other one. So t equals, let's times by 13, and divide by 12, and divide by u. So 42 times 13, let me just get my calculator out. 42 times 13, 546 divided by 12 is 45.5, and then as a fraction, what is that? That's going to be 91 over 2. Over u as well, because we're dividing by u. That'll go over there. So I'll call this equation 1, and I'll call this equation 2. So let's sub 1 into 2. I'll scroll down just a little bit. So minus 25 equals 5 over 13 u, and then sub this in 91 over 2u. Them u's will cancel out. And then I've got minus 5t, so minus 5, 91 over 2u squared. So minus 25 equals to 5 times 91 over 13 times 2, which is 26. So that's just them making 26. I don't know what 5 times 91 is off the top of my head, so I'm just going to leave it like that for now. And then this is minus 5 times by, well, this is going to get me 91 squared over 4u squared. So minus 5 times by 91 squared over 4u squared. It's not a bad thing to leave it like that, because 91 squared is going to be massive. So there's no point just writing massive numbers in our calculations when we understand what 91 squared means and we know how to deal with it. Where I'm going to go from there, I'm just checking I've done all of this right, because I didn't look at my notes for the last bit. We'll see how we get on. I'll backtrack if needs be. Probably going to times by 4u squared. So minus 100 u squared. I will need to get the calculator out to start figuring this out. So 5 times 91 times 4. That's 1820 u squared over 26. Let's divide that by 26, see if anything nice comes from it. Ah, that just goes to 70. So 70 u squared minus, well, 5 times 91 squared. God, that's a ginormous number. Okay, let's add this to the other side. Let's add this to the other side. Let's divide by 170. Gets me some pretty horrible number. And then let's square root. .606, etc. So u equals to 15.6, we'll call it. Again, we've used a as 10, so we should really be rounding it to one significant figure, but it just feels a bit off that we're rounding it to 20. It just seems way too far off for me to feel happy doing that. Okay, so that's my value of u, that's my speed. Maybe I'll just write that on the diagram here. Okie dokes, let's have a go at B. Give me some space here. Hopefully it's a bit of a shorter one, only 2 marks. So the time taken to get from A to B. Well, let's resolve going across. We know the speed here is 12 over 13u, and we know that that means 12 over 13 times by 15.606, etc. From our previous question. Oh, sorry. My bad. That should be below. That should be in u. So what? 12 over 13u, or 12 over 13 times by 15.606. We know that s is 42, more like it. We know the acceleration is 0, and the time it takes to get to B, well, we don't know that yet, but we could actually find it from this, couldn't we? T equals to 91 over 2u. That's my equation 1. So, why don't we find that value of t? T equals to 91 over 2 times 15.606. let me just recheck that. 15.606 is 31.212. 91 divided by 31.212 is so t equals to 2.9155. We'll call it 2.9 seconds to two significant figures. Actually, we don't need any of that. This was good enough. We just needed to realise we had the formula already. We found u. We could go back and find that. So no need. You could have done some Suvat thing here and found t actually, but same thing. We'd got the same answer. This is a little bit smarter way of doing it. And then C, the speed of the object when it is 22.4 meters above. Want to find the speed. Again, speed, we're trying to find this, and then that's my speed. So we want the velocity in terms of across, the velocity in terms of up and down. It's most likely going to be pointing downwards in looking at the picture. But yeah, so let's find that. 12.4 meters above the ground, that means 12.6 meters from the start, because we're 25 meters above the ground. If we go to 12.4 meters like that up here, we are 12.6 meters below. That'll be important for our displacement. So if I resolve upwards, the time we don't know. The acceleration is minus gravity, so minus 10 in this question. The speed is 5 over 13 u, and we know that that's 5 over 13 times 15.606. And the displacement is minus 12.6, because we need to go 12.6 down to get 12.4 above the ground. We wouldn't use 12.4 as our S value there. From here, we are probably going to, well, what can we do? We've got some values. Can we find the t? Oh, we don't want to find t actually. We want to find v because we're interested in the speeds of this. So we don't actually need that. We have enough values elsewhere. So let's go for v squared equals to u squared plus 2as because we've got all of them values. So v squared equals to that 5 over 13u value all squared plus 2 times minus 10 times by minus 12.6. If we find out what that is and then square root it, we will get, where have I got that? So v squared will equal to 288. So then v equals to 12 root 2 or 16.97. Just if we were to solve that, use the value of u as 15.606. We can be a little bit smarter with this. Remember, because the acceleration is 0, the speed doesn't change. So the initial speed is 12 over 13u, which if we were to sub in that value of u as 15.606, we know that that's 14.405. So that's my speed in terms of horizontal. This is my speed in terms of vertical. So if I create a little diagram from that, 14.405, 16.97, my speed is that direct across. So some Pythagoras, so this squared plus this squared all rooted, would get you 22.259, final bit of scrolling, so therefore, well, meters per second, so therefore 22 meters per second, rounded to two significant figures. Okay, so that's all that question done. Quite a big question. Yep, perfect. Okay, hopefully that was helpful.